So a system of equations involves both a linear function and a quadratic function is known as a linear quadratic system. You may see a linear quadratic system on your EOC or even a linear exponential or a quadratic system or an exponential quadratic system. All when you get something like that, it's going to be graphically, okay? You're going to solve it graphically. So I am going to solve this algebraically first. I'm going to solve it algebraically first to remind you that you do know how to do that. And then everything else we do is going to be using a graph. So the two equations that I was given were y equals x squared minus 8x plus 15. I do want you to write this down. And y equals x plus 1. I'm doing the algebraic method first. So if y equals this and y equals this, it says use substitution. Well, you just set these two things equal to each other. So that's what we're going to do. We're going to write the equation x squared minus 8x plus 15 equals x plus 1. How do you solve a quadratic equation? I'll ask that again since we should all know that. How do I solve a quadratic? I have to set it equal to 0 first. I have to set it equal to 0 first. So I have to subtract x and subtract 1 from both sides. When I do that, I have x squared. Let's see, a negative 8 and a negative 8x and a negative 1x give me a negative 9x plus 15 minus 1 is 14 equals 0. I'm looking for two numbers that multiply to a positive 14 that when I add them, I get a negative 9. What are those two numbers? What two numbers multiply to 14? Yeah, 2 and 7. I have to make them both negative. Yes. Was that you, Cameron? Yeah. Make them both negative. X minus 7 times x minus 2 equals 0. These are the factors. And what do you know about factors and their roots? What do you know about factors and their roots or their solutions? That is not true. They have the opposite what? They have the opposite sign. So if I have the factor x minus 7, my root is x is a positive 7, not plus. It's just x equals positive 7. If I have the factor x minus 2, then the root is x equals positive 2. So this is me solving it algebraically, but not really. I just know what my x values are. I have to plug them back in and figure out what the y value is. So if I have the ordered pair x equals 7, if x equals 7, well, what is 7 plus 1? 8. So that's my first solution. It's my first ordered pair. If I let x equal 2, what's 2 plus 1? Okay. So those are the two solutions. I'm going to plot those 2 points on my graph right now, 7.8 or 7, 8 and 2, 3. So I'm going to go to my graph. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to plot the ordered pair 7, 8. And I'm going to plot the point 1, 2, 1, 2, 3. Because those are supposed to be my solutions. Now I'm going to graph these two equations. I'm going to solve it graphically. Well, let's see. If I look at the linear function, I know that my slope, that's the number attached to x, is 1 over 1. That means I go up 1 and to the right 1. And my y value, my y-intercept is 1, and that's where I begin. So I'm going to begin at positive 1, and from there I go up 1 to the right 1, up 1 to the right 1. And I keep doing that. Oh my goodness, look at that. My line goes right through those 2 points. Well, it better because that's the place where the linear function and the quadratic function intersect. So they better touch that. So that's your linear equation. Now the quadratic equation. Let's see. Well, I'm going to move it down here. I know that if I want to find, like if I want to graph a quadratic, the first thing I need to do is find the axis of symmetry. I know you guys thought that was going to go away, but it's not. So the opposite of b over 2 times a. Well, that's the opposite of negative 8 is a positive 8 over 2 times 1. Well, 8 divided by 2 is 4. So 1, 2, 3, 4. I'm going to put a dashed line when x equals 4. I'm going to put a dashed line when x equals 4. Again, this is the only one that we're doing manually. So that's the axis of symmetry. It's the equation x equals 4. How do I find the vertex? Well, I take that fact that x equals 4, right? And I plug that into my my quadratic equation. So 4 squared minus 8 times 4 plus 15. Let's see, 4 squared is 16. 8 and 4 is 32. So 16 minus 32 is negative 16. Plus 15 is negative 1. So my vertex is the ordered pair 4, negative 1. Well, what are the two roots? Because we already factored this equation. No, we didn't. We didn't factor this equation. Let's factor it. Factor. Let's see. We have x squared minus 8x plus 15. Two numbers that multiply to positive 15 that when I add them, I get a negative 8. Negative 3 and negative 5. X minus 3, x minus 5. Well, those are the factors. So that means the solutions are positive 3 and positive 5. I know that my axis of symmetry is right here. So let's figure out what happens when x is 2. Let's plug it in there and see if I get this. Or what is the y-intercept? Do you guys know what the y-intercept is? 15. 1, 2, 3, 4, 5, 6, 7, 8. Can we count up to 15 on this? We sure can. 15. That's 1, 2, 3, 4 units away. 1, 2, 3, 4 units away. If I find out what happens when x is 2, when x is 2, y is 3, that's 2 units away, 2 units away. I think I definitely have enough points to plot my quadratic. So, looks like my solutions are the ordered pair 2, 3, and the ordered pair 7, 8. What did we figure out when we solved it algebraically? That exact same thing, okay? That exact same thing. All right, so now we're just going to use Desmos. So I want you guys to put this equation into Desmos. You have two of them. You're going to have a linear function that you put into Desmos and a quadratic function that you put into Desmos. You're typing them into Desmos. Put them into your Desmos, okay?
At the same time?
Yeah, put both of them because you want two equations on the line so you can find out where they intersect. You want two equations. So f of x equals 5x plus 3. And the second equation is g of x equals x squared minus 3x minus 17. So if I look at my graph, what do I see? Well, I see that I've got two equal signs in there. Where are the two places that these intersect? Well, what are the ordered pairs? That's one of them, negative 2, 7. Where's the other place that they intersect? Yeah, 10 and 53. So my solutions are negative 2, comma, negative 7, and 10, comma, 53. Has two solutions. Two solutions. Flip over to the next page. Flip over to the next page. We're going to do the same thing. We're going to plot these on our graph. Plot them on our graph. Only this time I'm not going to really look at the graph. I'm going to do something different. Hopefully you guys can notice something. So negative 8x plus 7. And my other equation is y equals x squared minus 12x plus 7. I am going to hit the gearbox and I want a table for both of them. I'm going to hit the gearbox and I want a table for both of them. Actually, well, yeah, I'm not even going to look at that. That's going to be easier for you guys when you're in your calculator, I guess. We'll do the next one on y equals on a calculator. So what are my two solutions? I don't, yeah, 4, negative 25 and 0, 7. So it says which of the following sets could be the x coordinates. So this just wants the x answers. So if I look at my ordered pairs, I have one ordered pair that is x equals 0, and the other ordered pair starts off with x equals 4. Do you guys see what it's asking? Okay, so answer choice 3. Okay. I'm going to do this one in my calculator because I want to show you what it looks like in your table. So I'm just going to go to y equals on my calculator and put both equations in on my calculator. Will you guys do that with me? Yeah. Y equals 2x minus 4 and y equals x squared. Use your calculator for this one. Y equals x squared minus 4x plus 5. Hopefully you guys are going to see that doing it on your calculator is almost easier than Desmos. When you go to your table, second graph, you have the same x value, right? You're looking for the two y values that are identical. You're looking for the two y values that are the same. Two y values that are the same. So I see that when x is 3, both my y values are what? That's one of my ordered pairs. Do you guys see it on your table? When x is 3, y is 2. Is there another one? I don't see another one. Do you? No. So, that just means that this one has one solution. That just means that this one has one solution. So I'll graph it so you can see it, but you guys don't have to take your time to graph it. So 2x minus 4 and x squared minus 4x plus 5. So do you see how the graph just touches the line right here at this point? At the ordered pair 3, comma, let me make it bigger, right here. It just touches at the point 3, whatever, 3, 2. It just touches at that ordered pair. That is called a tangent. When a line just touches a curve, they're said to be tangent to each other. All you need to know is that it only has one solution. That's it. Okay. Just know that it has one solution. We're not graphing it. Okay. We're not graphing it. So it's this bottom question though is important. How many different possibilities are there for the number of solutions on a quadratic? That is important. How many different possibilities are there? So I want to show you. So I'm going to make 3 little graphs and I'm going to do it right above. So my first graph, I'm just going to do this. Yeah, I do want you guys to draw this. I'm going to put a quadratic equation on it, and then I'm going to put a linear function going through it. So I have 1, 2 solutions. Here's an example where a linear and a quadratic would give you 2 solutions. My next one, I'm going to draw a like XY axis, and I'm going to put a parabola on there, and I'm going to put a linear function just like that. It just touches it. This is one solution. One solution. And then my very last one, I'm going to put my parabola way over here. Here's my parabola. And I'm going to make my line go like this. How many times do those intersect? None. So 0 solutions. So how many possible solutions can a linear quadratic system have? Well, they could have 2 or 1 or none. So you have to check, okay? 2, 1, or none. Got it?
Yeah.
So those are your 3 different possibilities. And that's it. That's your lesson.